What we're looking at here is we have all these blanks. We want to fill them in, but on the test, it's going to be true or false. So if every horizontal line intersects the function at no more than 1 point, what this means is, one, we have a function. So we're starting with a function, and the horizontal line test works because it's only going to hit the graph once. If that happens, this is called one-to-one. Okay, so that's a one-to-one function. Here we have the range of an exponential function. All right, the range does change based on if it shifts up and down. But here we just have a to the x, so that would be like a parent function. And if that's the case, we aren't shifting up and down. And then the range, if we have a is positive and not equal to 1, this is going to be 0 to infinity. So we would have an asymptote of x equals 0, and then it would be the graph completely above that. For every point x, y on some graph of f, the point we're looking for on the inverse, it has to be every single point's going to be switched, flipped. So we have y, x on the inverse. So for every x, y, we have a y, x. For the x-intercept of a log function, all right, if you remember your parent function points for log, it's going to be 1, 0, and then the base 1, and then 1 over base negative 1. So for the x-intercept, it has to be 1, 0. Okay, so again, notice for this parent function here, log base a of x, we aren't shifting left or right, so that's where your intercept would be. You have two one-to-one functions that are inverses of each other. If you have two functions that are inverses, if you evaluate f of g of x, so f composite g, and then you do g of f of x, both of those are going to equal x. Okay, so that happens anytime you want to verify inverse functions. You do the composite function both ways, and they both have to equal x. If that happens, we know they're inverse functions, and likewise, if they're inverse functions, we know this is going to happen.
Wait, do we solve for both of them, or is it them equal to each other?
You would solve this one, and then you would solve that one, and when you solve both of them, they'll both equal x.
Okay.
The graphs of inverse functions are reflections over what line? Y equals x. Good. All right, if you have the graph of y equals 1/4 to the x power, all right, that is going to be the reciprocal. What is 1/4 is 4 to what power? 4 to the negative 1. So here, this negative x, it's going to be 4 to the negative x. So these two functions are actually the same exact thing. So even though this would be a parent function with 1/4 as a base, this one would have 4 for the base, but there's a reflection over the y-axis. All the x's are opposite, so the graph actually ends up looking identical.